the moment we hit that inflection point, it's going to be like ChatGPT, that ChatGPT moment, but on steroids, where all of a sudden everybody's going to want to play catch up, but it's going to be too late. You're going to be left in the dust. Let's be frank. I mean, this is going to be one of the most transformational technologies ever. Like, they want to be front and center, and we can't let Russia, we can't let China get there before us, because this is the cyber equivalent of an atom bomb. Whoever gets
it's a Manhattan Project of our generation.
It is, but it just, this time, instead of the public sector working on it, we have private companies that are individually getting there, and we need more government support to get us there, because they need to be the ones that are effectively footing the bill to this, because if we lose this race, then we're screwed.
What is going on today, guys? So today I have Dominik Andrzejczuk, who is here with us. He is an OG quantum bull, an investor and managing partner of Atmos Ventures. And he recently had a debate with Martin Shkreli on quantum computing, and there were over 1,000 people on Twitter listening to that conversation. I found it fascinating, found it super interesting how he carried himself. So I invited him on the show to have a conversation with all of us just about quantum investing from his lens. And I'm super excited to have you, Dominik. Sorry about the last name. We both have really long, crazy last names.
You actually did great.
Did I?
Yeah.
Well, welcome. And thank you for agreeing and making time to come on the show and talk to us. And I think, recently we've been talking a lot to the CEOs, a lot of these private and public companies. So I think it'll be really interesting to get the capital perspective. And so my viewers can get a chance to get to know you a little bit better. Can you tell us a little bit about your background and what led you to quantum and all that?
Sure. So my, first of all, thanks so much, Majid, for having me. I have a physics background. I'm not a PhD, but I finished a bachelor's degree in physics at Villanova, and I got almost right out of college, got into the whole entrepreneurial scene. Moved from Philadelphia to California, did some entrepreneurial stuff, and then in 2014, I joined a venture capital firm called Partner of Atmos Ventures. I was still a young guy, mid-20s something. And one of the first deals that we did while I was there was in a company called Rigetti, which I'm sure you know. And we were the first institutional check into Rigetti. They had just finished their Alchemist Accelerator. And it was just Chad. He was the only guy on the team. And, I remember when we had first met him, just, the whole concept of quantum computing was something that was in the back of your textbook somewhere. It was an interesting tidbit. There was a little bit of talk around D-Wave, but there wasn't that much. And then Chad, he pitched us on this idea that he wants to build a quantum computer, and there's these things called superconducting qubits, and they can be manufactured using standard CMOS fabrication techniques. And so we wrote him a check. We, Murado and Ame both collectively wrote him $1 million check. And then he went out to and leased that place on Hines Street, the old ketchup factory. And, I fell in love because it was physics is very near and dear to my heart. And, here's a company who's actually doing something that isn't just SaaS or enterprise software. And so we were there when Chad got, those first few deliveries of his cryo fridges. So, we were front and center, and I was very much active with Chad and the rest of the team when we went out to raise the Series A. And it was an interesting experience because, back in those days, and I like to kind of use an analog, the analog I like to use is, back when self-driving cars were kind of a thing in the early 2010s, a lot of these companies that were doing self-driving had to build the entire stack from the ground up. There was no LiDAR that you could buy off the shelf. You had to build your own LiDAR. It was the same thing with quantum. Quantum has just so many layers of the stack. I mean, you've got the QPU, you've got the cryo fridge, you've got control systems, you've got the software that controls all the control systems, you've got the application layer. So it was wild because, Chad and Rigetti, they had to build the entire stack from the ground up. There was almost nothing off the shelf. And I remember when we were doing the Series A deck, there was a slide in the Series A deck that by 2018, we'd have 1 million qubits, right? And then obviously physics got Yeah, physics got in the way, and so we learned a lot. And one of the things that I remember doing some fair bit of traveling with Chad was, we spent a lot of time in DC, and there were all of these, high performance computing conferences. And at that point, we were pitching the idea that we had a quantum computer to, both the public and the private sector. And that's when I began to sort of see, oh wow, like governments are really interested in this stuff. And then in 2017, I wanted to do more deals in quantum. Met Jeremy O'Brien in a park in Palo Alto, and he was just about to found PsiQuantum. We almost did that deal, and we didn't because we thought it was conflicting with Rigetti. So unfortunately, we didn't do that deal. But I wanted to do more deals in quantum, so I actually found out that the tip of the spear of all research and development in quantum was Europe. There was a lot of interesting stuff happening in the Netherlands, in the UK, and France. So I left in 2018, set up my own fund in 2019, and then 2020 we did our first two investments, which was in Oxford Ionics, as we all know, and Orca Computing, which is a photonics-based quantum computing company. So as you know, Oxford went public. Was acquired by a public company, and Orca still continues to carry on to this day. So that's just a quick background about me.
We just actually had CEO of Orca on the show when we spoke with him.
Oh, no kidding! You got that, Richard.
Yep, he's awesome. And he's got a great voice. I told him that he should narrate nature documentaries.
Oh, for sure.
Yeah.
No, Richard's a great CEO because, he's a PhD. He's highly technical. And, like Chris Balance at Oxford, they actually know how to communicate with people. And this is always the challenge in, because quantum computing, the engineers and the physicists, man, some of them, you need to have an interface to communicate with them. You can't just have a normal conversation face to face. And sometimes academics will scoff at that. But, if you really want to build a business and you want to sell your technology to whoever, I mean, you need to know how to communicate. And Richard is, he's highly talented in that regard. And he actually understands the concepts that he's selling too. It's not like, he's just like me, just a bachelor's in physics. He actually, is in the trenches.
Yeah. So tell me, you did this backing of Oxford early on. So how did that all work out with IonQ and their acquisition of Oxford?
Yeah. So, first of all, the industry is so small, everybody knows each other. And, especially once you get down into a particular architecture, right? Trapped ions, Chris Monroe knew, Tom and Chris from Oxford Ionics, for years. I mean, they worked together. They've, exchanged notes on papers and collaborated on a number of things. And obviously Chris Monroe, he's old school, man. That guy, I'm pretty sure invented two-qubit gates. And so we did back in 2018 when I had moved to Europe. We had going back to the Rigetti days where there was the slide with the 10 million qubits by 2020, and we're going to solve all the world's problems. What at least I began to realize is, okay, what are the physics and engineering roadblocks that superconducting qubits, what are those roadblocks and those challenges that they had to overcome? And primarily it was around scaling. As the moment you begin to scale these superconducting chips, you get a lot of crosstalk and you get a lot of noise. And so it wasn't a simple, hey, we'll just, figure out how to do 1 or 2 qubits on a chip and then, grow them a la Moore's law. But instead, what you had was a lot of noise, and that's what was ultimately the limiting factor for scalability in those chips. So I went back to the drawing board, and I was like, okay, well, we definitely want to have an architecture that can scale and that can scale reliably. And CMOS is great, right? Boring engineering, pre-existing supply chain. So let's stick to CMOS. But the superconducting qubits are kind of lousy because they're kind of like artificial atoms, right? You have these capacitors on a chip, and because they're not a perfect atom, they're just not very usable. And so we went back to see, okay, well, who or what architecture on the market has the best quality qubits? Who's been able to demonstrate the best coherence times, the best gate fidelities, etc.? And so we worked with a professor. He was at the Warsaw University of Technology. And he said, well, we think that they're ions, few and far in between, because you can connect them all. They're actual atoms that you use. And so you don't have to, create this artificial atom or mimic the properties of an atom, because you're actually just using atoms. And he was building the control systems for Oxford University, and not just Oxford University, but he was, this guy was shipping. He built like an open source hardware platform called Sonara and Arctic, and he was shipping these FPGAs to control qubits at University of Maryland. So some folks at IonQ, in Innsbruck, at the University of Innsbruck and AQT, and University of Oxford. So he put us in touch with Chris and Tom, and he was like, "Man, these guys are really onto something, because unlike all the other trapped ion architectures that control their qubits with lasers, these guys are using standard electronics." And I think they're really onto something. So, myself and one of my other partners, we flew out to Oxford, we met with the team, and half of private equity venture capital investing is, you want to make sure that the tech is solid. You want to make sure you've done your due diligence technically, but also there's an element of a psychological element. So, how well are you getting along with the founders? How well can they communicate? And can they actually sell, a team of 10 to 100 people that they can hire to get on board with their mission? And when we met Chris and Tom, it was like, okay, yeah, these guys, not only are they super smart and clever, but they're also they feel like good founders and good CEOs. And so that was in 2019. And then we wrote them a check in the summer of 2020. And that was I think it was to the tune of, don't quote me here, it was £1.5 or £2 million. And then we were off, and it was all in the middle of the pandemic too, right? Everything was, it was nuts. It was chaos. Nobody was funding anybody. Everybody was scared. Everybody thought the world was falling apart. And so, we got quite lucky, and we wrote them their check, and that was it. And, and obviously that investment's panned out, because the whole thesis, which was focus on good quality qubits that have a very good potential for scalability, panned out for us. And Tom and Chris and the entire Oxford Ionics team, I mean, they always, they knew the IonQ guys, and they were always, in close contact with them. And then finally, when the acquisition actually happened, I mean, it all happened, within a matter of weeks. It was nuts. Back in May and June. And, and if you just look at the stock price, I mean, you can see that the market, really received it very well, because the moment they announced that the UK government had actually cleared the transaction, IonQ stocks just went, parabolic. I mean, it went up 100% in just a matter of weeks.
Yeah. And we also saw in the same time frame, Vector Atomics and Capella Space and LightSync and all these other acquisitions outside of Oxford that IonQ is doing at a similar time. And then that's when I'm like, holy crap. If this was a bigger company, then there'd be antitrust issues here, right? Because you're pulling together so many giants in the industry, basically building this crazy team. And every time I hear Chris talk, he's like I feel like I could have a beer with this guy. He could explain this to a guy like me that could barely understand. He could explain it so I could understand. And so I do have a question for you. So after this acquisition, so sounds like that was a very successful early bet on Oxford that played out very well for you guys. Recently, they announced this 99.99% 2-qubit gate fidelity. And I think the market doesn't understand what that means. I think they just see it as just another number. This is just another research point. But I think it's much more important than that. And maybe you could help shed some light on that, or give your color on that.
Yeah. So I like to, if we could do an animation or something on the video, it would be very useful to show the audience what does that exactly mean, right? So now, gate fidelities are very important, because classical computers also are error prone. It's just that the error rates are 10 to the minus 11 or 10 to the minus 12, right? But back in the early days, when there were still when integrated circuits were still a relative novelty, or when we were still using vacuum tubes. I mean, you would punch data into a computer, and there was a chance that the calculation that you would receive in return was not was false, right? And so when it comes to running quantum algorithms, you have something called circuit depths. And right now, circuit depths are really the biggest pain in the ass when it comes to designing useful algorithms on these near-term quantum computers, because the quantum computers are very error-prone. And so what I usually like to do is like a little bit of a math exercise. So if you take 4 nines, so 0.9999, and let's say you want to simulate a number of gate operations with those types of fidelities, you take that number 0.9999, and let's say we want to run a circuit that has or an algorithm that has a circuit depth of around 1,000, which means that you have to run the same calculation 1,000 times on the quantum computer. So we do 0.49 to, let's say, the 1,000 power, and our end result is 0.905. So meaning that after we run that algorithm, the result that we get, there's a 90.5% chance that that result is correct. Okay? That's for 4 nines. Now, let's pretend, let me see if I can pull up, let's say we do, instead of 4 nines, let's just do 2 nines, right? So let's put an earmark in that. Let's do, 90.5% is 1,000 circuits with 4 nines. Let's do 0.99, so 99%. And let's also raise that to the power of 1,000. So run the same algorithm. And now we have 0.00004317, meaning that if we have a quantum computer with even a 99% 2-qubit gate fidelity, and we run that same algorithm, there is a 0% chance that that computer will actually yield us an accurate result, right? So all those nines really make a huge difference. And really, like with a lot of the algorithm developers that I spend time with, they have to figure out how to take those algorithms and shrink them in size, right? So that the circuit depth is what they call shallow, so that you can actually run useful algorithms. And so instead of actually, and that's like, I don't know if you've got any experience in writing, code or programming with Python. It's like, you might have some spaghetti code, which is 2,000 lines long, and you can't run on the computer because the computer will run out of memory. So you have to figure out how to shrink that piece of code down from 2,000 lines to like 20 lines. And it's very difficult. It's very challenging. It also makes it virtually impossible to run any kind of software. And you're right. It's a huge deal that I don't think the market really understands, because, from a regular person that doesn't do any of this stuff, like, you're thinking to yourself, okay, well, what's the difference between 99% and 99.99%? I mean, that's barely 1%. Well, when you actually run the math and you run the numbers, you can see that the effect is profound. And so what that allows the IonQ device to do is allows them to run these more complex algorithms. And this is the thing is these are physical qubits we're talking about, not logical qubits. So you can, and I've interacted with a lot of quantum physicists and engineers that are designing algorithms. If you tell them that you've got a device with 120 qubits that have 4 nines of fidelity, man, they're over the moon, because they know that, hey, we can actually start demonstrating some examples of quantum supremacy on a device like this. So, I've got guys that are like, foaming at the mouth to get a hold of, even 56 qubits. There's even, and I've posted this before on my X page. There's a guy, his name is Olivier Ezrati. He's a French physicist. He posts this Understanding Quantum Technologies book every single year, and he's got a nice chart that shows, okay, where are we? How far away are we from useful quantum computers? And on the x-axis, he has the error rates for 2-qubit gates, and on the y-axis, he has the qubit count. And really, I mean, if we get to 100 qubits with 4 nines of fidelity, like we're almost there to be able to demonstrate very narrow use cases. Like, I'm not saying that we're going to, cure cancer or something like that, but we will be able to show and demonstrate quantum supremacy and quantum advantage in very narrow use cases.
There's so many questions I have, But so we just talked about that 99.99 and the importance of it. So now what do you think the implications are for their roadmap? Because they've come out and they're one of the most aggressive. IonQ is super aggressive with their roadmap, saying 1 million qubits by 2030. I mean, I don't want to say that's the exact number, but they have just a very aggressive, fault tolerant, and very aggressive qubit count on their roadmap. Does this 99.9% unlock the possibility that could actually practically happen?
Yeah. So in theory, I believe that that their chip has a theoretical upper limit of 1 million physical qubits. The question is will they get to that? I'm not 100% sure, but it is within the bounds of physics for them to do that, right? Now, the one thing that we have to be cautious with, and here I'm cautiously optimistic, is as they begin to scale from 56 qubits to 1,000 qubits to 10,000 qubits, I'd be interested to see the data around whether or not their two-qubit gate fidelities are affected as a result. Because ultimately that's what happened, way back in the day when Rigetti started to scale up their chips. Once you started to scale up the qubit count, man, the noise just went nuts. And the reason why I'm cautiously optimistic is because I've been here before, so I don't want to
Yeah, absolutely. And that's the perfect insight to have, is like not just this narrow tunnel vision of just unadulterated bullishness, but also I think cautious optimism, reserve, holding. I think a lot of people expect results today. And we're very much on the cutting edge of technology, with these things, and we don't know, you can't just say in when the iPhone 1 was created, right? That was the hardware moment. And then there were still lots and lots of years before the software got really good on them.
Yeah.
And I don't even know if we have the iPhone 1 for quantum computers yet. We're pre-iPhone 1 maybe.
No. I mean, we're still in that 1970s, 1980s phase with mainframe computers.
x86, yeah.
Yeah. And so and there's a great quote from he's the founder of, I don't know if you're familiar with a company called StrangeWorks. And God, I'm blanking on his name. He's going to kill me. I'm horrible with names. But there's a quote that he always uses at conferences, which is, if a fully fault tolerant 10 million qubit quantum computer were to just show up in the middle of Park Ave in New York City, it would take several years for us to figure out actually how to run programs on it and run applications. It wouldn't do anything, wouldn't move the needle for us necessarily today, right? Yes, there is this, Peter Shor obviously wrote Shor's algorithm back in the 90s. And so there's a mathematical component to designing good quantum algorithms, but it's just like any good computer scientist. I mean, you need to be able to run some of your algorithms on an actual device to see, what results they yield, and then you kind of learn from that. So, and this was something that I was pretty, I wanted to make a point in my talk with my spaces with Martin, was that, we're still, as far as quantum computing is concerned, I mean, we're still probably around 5 years out before we start to see real commercial advantage in applications. And from my perspective, that's quite enthusiastic compared to, the rest of the market. But that doesn't mean that there's not going to be any revenue coming from that, because a lot of the bigger companies, the big corporates, the big enterprises, I mean, I've seen, firsthand, especially with my own quantum companies, they are investing money so that they can learn and so that they can understand, how do we design good algorithms that are useful for my business. And they also understand, this is probably, 3 to 5 years of runway before we can actually do something useful. But the moment we hit that inflection point, it's going to be like ChatGPT, that ChatGPT moment, but on steroids, where all of a sudden everybody's going to want to play catch up, but it's going to be too late. You're going to be left in the dust. And so it's important to note that yes, like these devices, they're going to be noisy, they're going to be useless for at least another several number of years. But that doesn't mean that they're not going to produce any revenue, because a lot of big companies and the government and the public sector are going to want to figure out how to use these things before our adversaries do.
Yeah, and IonQ uses a term. They use a term called narrow quantum advantage, right? Or that's what I've heard from them and their team. And then you have companies like D-Wave who released a peer-reviewed scientific paper showing quantum supremacy in a select problem for materials lattice. So to say they're completely useless at this point in time, I think we're starting to get that trickle of niche use cases, and that trickle may start to open up maybe a little bit more over the coming months, years. So I started covering this space in 2025, but you've been around the space for over a decade. You've been talking to these companies and the founders of these companies and actually investing in the companies. So from your perspective, has 2025 been different? Or do you think this is a hype cycle? Do you think it's bubbly, frothy? Or do you think that the market is starting to recognize the potential of everything?
So the thing about, in the last, 12 years of being in this game, obviously, like, quantum is very cyclical, right? Because I've already been through two quantum winners. And the first quantum winner was, it must have been 2018, 2019, when things settled down, valuations went down in the private markets. And that's when we started to see, like IonQ and all the other larger companies begin looking for exit liquidity, because that exit liquidity wasn't available in the private markets. So you had all the SPACs and the, reverse mergers and whatnot. And then after that cycle, we had, Scorpion Capital. Like, I remember like it was yesterday. And it's so funny because, the Scorpion Capital report came out in, was that 21? I think it was 21. Yeah, it was like the fall of 21 or late summer of 2021. And it just, ripped IonQ a new one, because they were like, oh, this is a fraud. And there was all these, employees that were disgruntled about, the management being dishonest. And man, that brought the whole industry just, down. And it actually, negatively impacted our investment thesis, because then we were just like, maybe we should, chill out on the quantum investments, because this is pretty damning. And it does seem like, and at that point also, Silicon Valley just went completely like anti-quantum. And it just also started this groupthink, which still exists, right? And now, what was it, starting last winter when IonQ and all the other quantum companies, went from like $1 to $20 overnight. And I believe that was on the heels of, if I remember correctly, Google had published some paper.
Yeah, Google will.
Yeah, and so that then that brought everything back up, and then Jensen crashed it the next day by making some comment at CES, and now we're sort of back, and the difference this time is. The amount of the total market cap of all the quantum companies on the market today is, probably getting close to 50, 60 billion, right? So the difference now is that you have a ton of exit liquidity, right? Potential for privately held companies. And you also, the other difference now is like, now that the whole like quantum stack has become more and more well-defined, a lot of physics problems, or what were perceived as physics problems, have now kind of turned into more engineering problems. And these engineering problems are better known. And you can make investments in like small private companies that are tackling this very, very specific problem within the whole stack. And then you have somebody like an IonQ or Rigetti that can acquire those companies because, they're sitting on a pile of cash. That's the main difference this time. I mean, are we in another cycle? Probably, right? Like, I mean, these things go up and down, but like, again, this is the same question I asked Martin, like, what's your investment horizon? Are you trying to short this for like 6 months because you think it might, or do you just, keep accumulating over time and your investment horizon is 5 or 10 years, right? Like, I think it's good for us to focus on like, what is your investment timeline, right? If your investment timeline is 5 to 10 years, oh yeah, I mean, we still definitely have more room to go, but maybe now a little bit frothy. I'm not sure.
Yeah,
right?
Yeah, and we have, and as investors, we have to speculate about this all the time and determine our risk, and every investor is a little bit different. This burning question, and it is this contracting timeline, and this is going back to that Jensen comment, which for those who don't know, I think most people at this point know that Jensen Huang, the CEO of NVIDIA, made a comment at the start of 2025 that tanked quantum stocks 60, 50, 60, 70% virtually overnight. Like there was a mass exodus, mass fear event that caused essentially a mass exit from investments in quantum. And since that time, most of those stocks are double, triple what they were even beyond their high point, right? Or they're substantially, the valuations are substantially higher. And the question that I have is, this is the leader of the biggest tech company and biggest company in the world by market cap, saying this is 15 to 30 years away. And now later in 2025, saying quantum computing is at an inflection point, and investing in PsiQuantum and Boston Research Lab and other ventures like quantum computing investments through their N Ventures arm. So seeing that 180-degree sort of just flip, do you think that maybe like the Zuckerbergs and the Jensens of the world are a little bit worried that maybe this is coming faster than they thought?
Yeah, well, let me give you some context around, because I've been working with NVIDIA's quantum team for quite some time. I mean, I remember in 2022, a very good friend of mine, he was a portfolio company within Murado. They got acquired by NVIDIA, and he had some very senior position then later at NVIDIA. And then in 22, he calls me. He's like, "Hey, listen, I can't tell you exactly what's going on, but apparently NVIDIA is building a business unit. Apparently it's the only business unit that they know is not going to net them revenue for like the next couple of years, which is very bizarre for NVIDIA. Like NVIDIA, if they put up a business unit, it has to like make money." And he's like, "I know you've been talking my ear off about quantum. Now NVIDIA is doing something with quantum." And this was in 22. And that was when NVIDIA launched, it was either CUDA Q or Q, it was Q Quantum, which was like some fork off of CUDA. And then it was actually at that time, I helped co-found a company that was in the data center space that was meant to like do hybrid computing, so connect quantum computers with classical computers. And NVIDIA was super interested, right? And so we had talked about deploying GPUs in Poland. We would have all the infrastructure set up. So I saw then that and even having conversations with folks internally at Ventures, they said, "Yeah, we're not going to invest. We're not going to invest in any quantum hardware companies. But we're very interested because we see where this is going, and we want to figure out a way to grab a piece of that." And mind you, this was 4 years ago, right? And they only kept growing the team bigger. They had more and more product managers. They were launching more tools and products in their entire quantum stack. And so when he said that was that this year? 25, right?
Yep.
January 25.
Yeah.
It was bizarre because it ran completely counter to every single person that I've been dealing with at NVIDIA internally, like for the last 4 years. Like it just, I had a pretty intense cognitive dissonance about it. And so to answer your question, are they afraid? I mean, potentially, but on the other hand, like QPUs are not going to replace GPUs the same way GPUs didn't replace CPUs.
Right.
And so, maybe, and I tweeted about this a couple weeks ago about where does NVIDIA fit in all this? The control systems you have, just above the QPUs. Above the control systems, you've got the error correction codes. And a lot of the control systems and error correction run on FPGAs, right? Because FPGAs are just far more performant. They're far more versatile, but obviously you need to know how to program a GPA, which is not trivial. And AMD bought Xilinx, and Xilinx is the premier FPGA that almost all the quantum researchers use for both control systems and for error correction. So does that mean, obviously NVIDIA wants to figure out, where it fits in that entire equation, because quantum computing in the next 10 to 15 years it's going to be hybrid, right? Whether we like it or not. And so are they afraid? Maybe like a tiny bit, because they don't know where this is going to go, because there's more unknowns than there are knowns. But they certainly want to figure out how to capitalize on this, because what Jensen said in January just doesn't make any sense with what I was dealing with for 4 years, dealing with the people at NVIDIA. So and maybe they feel a little bit threatened by AMD, because AMD owns the entire Xilinx FPGA platform, and maybe they feel like, because GPUs are great at certain things, but they're not really great at controlling quantum hardware. Could be used in quantum error correction, but I get the sense maybe they want to get to a much lower level to understand, the computational physics behind how quantum computers work. And so, is it fear? I'm not sure, but I know for a fact that if it's NVIDIA's only business unit there today is not making any money and they're just keeping it around, then for sure they see that as a massive, massive opportunity in the future.
Yeah, that's interesting to hear you kind of talk about the internal movement in the company and how the CEO's comments were a little bit inconsistent with even where they were placing their own bets. And there was speculation that maybe he said that because after he came out and made that comment, he also said, I didn't realize there were any publicly traded quantum companies. And I've kind of wrestled with that, whether or not I believe that, and
I don't believe it.
Yeah. But, steering to kind of like what I hold dear in all of this, and why even I made this channel, and that was a main catalyst, was because you had Jensen saying one thing, and then Alan Bratz of D-Wave coming on CNBC the next day and saying Jensen's dead wrong. And it's like, well, and everyone at that point in time was laughing at Alan and saying, who's this random Canadian CEO that's talking like this to our God and Emperor, whatever, and it turns out, D-Wave's had a heck of a year. And I'm just wondering, now that we're kind of like, there's always sort of this friction between what has been and what's on the horizon. You use this term, the unknown. So I want to give you maybe the ability to be like your most bullish self. So you've been in this sector for a long time. Assuming that we have, let's just say, let's assume perfect execution on IonQ's roadmap. And without it being in front of you right now, it's a lot of qubits. It's like 1 million physical qubits, 1,600 logical qubits by 2030, or maybe even more. What can we do with that, and how would that start to have an impact on things?
Yeah. So I'll put my tin foil hat on here for a second too, because this is one of my favorite questions. And if you read lots of physics academic papers on this topic that look at, hey, what are the hypotheticals in the future? One of the things that is brought up quite frequently is, we've as the human race, we've never entangled complex systems of millions of particles before and tried to control them. And wow, what sort of physics can we possibly discover by doing that? And because we have no idea, we've only entangled, maybe tens of particles, and we've done some operations on those tens of particles, but really, like, we have no freaking clue. And that can go both ways, right? That can go in the direction of, oh my God, like, we just don't know how to control this stuff, and the physics is just unknown. We need to invent new physics to figure out how to control this. Or it allows us to, I don't know, we could learn how to create artificial sentience or artificial consciousness. And there's, going down the tinfoil hat route, like, there's been a lot of research around something called, quantum consciousness or the quantum mind, where we still don't know, like, scientifically speaking, like, what is consciousness? Where does it exist in the brain? And there's been a number of experiments done to figure out, whether or not consciousness is a local or a non-local phenomenon. And more data points to the fact that it is non-local, that perhaps maybe the electrons in our brain, as they're going up and down, the neurons, they teleport to some other dimension in this 10-dimensional universe that we live in. And so the universe in some sense has this like back end, right, where we're all wired into a back end. We can't see it, but all we can see is the user interface, which is 3-dimensional, 4-dimensional world. And I always go back to I use the example of the movie Avatar, right? You've got the guy who's paralyzed from the waist down. He goes into this machine, and his consciousness gets transported to this creature. And technically speaking, I mean, if you look at quantum mind and quantum consciousness, like, that isn't exactly too far out from the realm of physical reality, right? Like, will we be able to transport our consciousness somewhere else? I mean, we can kind of do that today with, like, psychedelics and that kind of stuff. But a lot of quantum mind, quantum consciousness is tied also together with research in psychedelics. Why do psychedelics act on the human mind in the way that they do? And why do these people feel like they are, transported into different realms? So that's where, I like to really dream and think about what are the unknown unknowns, because every single time humanity has come up or discovered some new principles in physics, it's had profound implications on society, right? So, electricity was discovered by Coulomb back in the 18th century, but it took, a full 150 years before it actually had any real impact on humanity. Obviously splitting the atom had a massive impact on humanity, especially with energy and with weapons. And we still don't really understand quantum physics that well. Like, what does this mean? Like, nobody could have guessed in the 70s that the invention of the transistor would be able, we'd be able to be speaking while you're in Oregon and I'm here in Nevada, right? It just, we wouldn't have been able to conceive that. It's the same thing with quantum and quantum physics and quantum computing. Like, what roads will that open? God only knows.
Yeah. And it's also like, we need to also for a second step away from the markets and just think about where we are in human history, right? We're the only humans ever to live that have had computers in their hands that are also cameras, that are also connected to everything and everyone at all times, and are powerful devices beyond what we sent up to the moon decades ago, whatever. You can, if you think about it in terms of just in a short lifetime, like how much technology has changed the world, then it isn't like a question of will technology continue changing the world. It will definitely continue changing. It's just a matter of how much, right? And like something that I come back to with quantum computing, and as a first principle for me as far as an investor, I think it's important as just to have a solid thesis when you invest. First principle for me is I look at the landscape of computing and the demand for computing and how it's such a hot commodity in the world right now with all these data centers and build outs and that type of thing. Are we going to need more or less advanced computing in the future? And the answer is always, we're going to need more. We're always going to need to have, humans have quite literally tricked rock into thinking, right? Or synthetic thinking, or however you want to boil that down. but now we're like going to the level of the atom, which if you want to get like philosophical or wax philosophical for a second, I don't think we were even ever meant to do what we're doing with quantum computing, like the building blocks of the universe, manipulating individual atoms and running computations through them. So we're really at a fascinating point in this whole, in all of human history when we're having this discussion. And that's one of the things that excites me so much about this space and the unknown unknowns, as you put it.
Absolutely. And then even the known knowns, which is like a common use case for near-term quantum computing, is nitrogen fixation. So how do we model the FOMOCO molecule that exists inside of different types of microbes that can take nitrogen from the atmosphere and turn it into ammonia, right? Like this is something that costs, I think, 3% of the world's energy, where we use the Haber-Bosch process. So we can take nitrogen from the atmosphere and create ammonia. Like just this one super narrow use case. If we can figure out how to be, work like nature and be super efficient, so that instead of wasting all this energy for creating ammonia, we can do it at atmospheric pressures and ambient temperatures, then right there, like the amount of value that you can create by saving that much natural gas or oil or coal or whatever, that known is something that near-term quantum computers can actually tackle. And that's very exciting, because then as these computers become more and more complex and they can do more and more operations, I mean, it all comes down to being able to simulate nature the way nature intended it to, right? And those are the known knowns, and that's enough to get excited about. And so, I like this whole like elevated accelerationism ideology that exists online. And I think, personally speaking, anybody who's short quantum is a decel. Like we need to be accelerating this specific tech sector more and more, because like, man, it will change society in ways that we're not even able to conceptualize or theorize. And going back to how do we get to AGI? Well, if you want general intelligence, you have to be able to mimic general intelligence that we understand, right, as humans. Well, our minds probably have some element of quantum within them. So if we want general intelligence probably has to be quantum. So if we want to get there, we need to push the envelope. We need to continue investing. And that's what I'm doing, at least in the private sector.
Yeah. And you're like, when you think about the pair of quantum and AI, and that could be a whole other conversation that we have in a separate interview, but quantum and bringing AI and quantum together, that alone, like we just had the ChatGPT moment 3 years ago. We had 10,000, 20,000, 30,000, like you can go back in history as far as you want to, where we had the most blunt instruments to do things. We were in 200, 300 years ago in the Civil War, we were loading one pellet at a time in rifles, and that was the most advanced technology. So just like the profound leaps that technology has been making since really in our lifetimes is worthy of note. And that is, when you use the word value, and that's the sticking point, I think, for the you mentioned also the shorts of quantum, is like these valuations are too crazy. These companies don't make any money. And I agree that on valuation alone, yes, if we're just looking at valuation, like there's a lot of companies that make a lot more money and have a lot lower stock price. Like we can agree on the valuation, but what is value? What is value to society? What is a valuable technology? What could quantum computers do for society to move society forward? And I don't think quantum computers have even yet had their own GPT moment. So the question is, when is that coming, and where is that coming from?
Yeah, and we probably, I don't want investors to hold their breath to think that it's right around the corner. It's not. And I think that, companies like IonQ, especially with acquisitions like Vector Atomic and whatnot, they understand that you need to have, this entire stack vertically integrated into your entire product or solution that you're offering to customers. But a lot of the stuff that comes from sensing or communications, right? That all eventually does tie into the quantum computing platform. And the other thing is, going back to, usually when there's a transformational technology, your first customer always ends up being the military or the government or the public sector. And, that's like with transistors, right? Like, one of my favorite bits of history is that during the Apollo program, so Fairchild Semiconductor, who designed and manufactured the first integrated circuit, their primary customer was NASA and was the Air Force. And they shipped for 10 years tons and tons of integrated circuits so that we can get a man on the moon, right? And it wasn't until around the 80s when a lot of that started to change and public sector customers became, a little bit, as far as the percentage of revenue became much smaller, and then private sector came along and those use cases became more and more apparent. I mean, the same thing's going to happen with quantum. And what we're seeing right now is, DARPA investing tons of money in compute sensing, DIU doing the same thing. So a lot of these use cases are coming from government, from military, but eventually they're going to enter the private sector and the civil sector. And the thing is we need that. And like, if history is repeating itself, like, again, I go back to anybody who's short quantum, like, just look at how much money is being invested by not just the US, but like globally, right? China, the European Union, individual countries in Europe. I mean, they're investing tons and tons of money in order to get them to be, let's be frank. I mean, this is going to be one of the most transformational technologies ever. Like, they want to be front and center, and we can't let Russia, we can't let China get there before us, because this is the like cyber equivalent of an atom bomb. Whoever gets
it's the Manhattan
control,
Project of our generation.
It is, but it just, this time, instead of the public sector working on it, we have private companies that are individually getting there, and we need more government support to get us there, because they need to be the ones that are effectively footing the bill to this, because if we lose this race, then we're screwed.
Yeah. And I don't think people really think that through, because we live in like this, in the US equity markets, especially, like this comfortable little bubble. Like, we have all the best companies and they're all so great, and all the best tech companies, and everything's awesome. But a very, very big equalizer would be if China had a sufficiently powerful quantum computer to crack RSA, then suddenly the valuations of, people like to talk about valuations, suddenly all those companies like that didn't do enough pre-work prep for this Q day, right? That who knows when that's coming, then suddenly they're not as valuable. We want to talk about a market crash, a black swan event, unlike any we've seen. Like, I don't want to get too hyperbolic, but if there is that power to pull back that layer of security, that layer of safety, that bubble, right, that has been the dominance of the US equity market for such a long time. Like, there are national security concerns, and there are, these are people's retirement accounts. These are people rely on the US stock market to live. A lot of people do, especially the older generation. So there are implications for this, for sure, and there are consequences to inactivity or inaction or not taking it seriously. And it's unfortunate that there's so much noise and distortion around this, where it's an unfortunate feature or bug or whatever you want to call it of the market, where there's financial benefit both ways if a stock moves in either direction, and there's financial motivation to muddy the water, to create fear, and it's unfortunate, because I think it could lead to some bad places. I'll just leave it there.
Yeah, well, there's also, like I'm a noob when it comes to public markets investing. Like, I let my banker do all that stuff for me. But I remember even having a conversation with him recently. When I went to Villanova, which has, a great business school, and and I took like a business or a finance elective, and it was like around investing in public markets. And I remember my professor then, this is 2009, 2010, like they were saying, oh, if a company has a price to earnings ratio of like 10 or 12, that's way too expensive. And, don't even touch that company. You want something around like 4 or 5, right? And now, like, if you see something with a PE of 10 or 12, right? Like that's a bargain, man. Like you want to get in there and you want to buy that stock. And so, I was having this conversation with my banker, and I was like, these valuations are through the roof. I mean, you've got PEs trading in the hundreds, and he was saying, like, listen, like that may be the case, but this is a different market. Like investors are investing in, they clearly just have different norms these days. Like, and these norms will change over time. And to your point, like, yeah, like are the valuations overinflated? If you're looking purely at earnings and revenue, yeah, perhaps. But then you got to tie in all this other, like, national security stuff, and also the potential that we talked about what quantum computing and sensing and just quantum technologies in general are capable of doing. And when you actually look at the capabilities, like, compared to conventional technology, I mean, you can do things either 10 times better or 100 times better, or you can do things that were impossible to do using conventional technology. So maybe that's baked into the price. And, you've got this Heights Capital Management, they wrote 2 checks for $3 billion, and they paid, every single time a 25% premium on top of that. So what do they know, right? Like, okay, fine. Maybe for them, $2 billion is just a drop in the bucket, and they've figured out ways to manage risk, et cetera. But I mean, you've got big dogs that are in the game that, and I'm sorry, but even 200 million, 20 million, I mean, you lose 20 million in LP's money, then that LP will sue you. So they must know something, or at the very least understand the technology, or at the very least they're able to do that cost benefit analysis, risk reward, where yes, this is insanely risky, but my God, the reward is we're creating a new market.
Yes. And that is impressive that IonQ has been able to raise at a premium, not once, but twice, and in massive amount of money. And it does beg the question, what do those investors know that we don't? But we also know a lot about IonQ. And I know you mentioned this, and I want to come back to this. Like earlier, you said that GPT moment isn't around the corner. It's not soon. You don't want to get investors' hopes up, and neither do I. Like in every single, almost every single video, I have to like make a point that quantum stocks are a risky investment. Should always contact a financial advisor before making any decisions. They're very risky, whatever, all those disclaimers. But when you have like something like the IonQ, and then you mentioned also Moore's law, right? Like this kind of like linear stair step up in better computers over decades, right? Better GPUs. So I tweeted about this today. The 1999, we had the NVIDIA GPU, the first GPU, and then 25 years later, we got Blackwell. Yeah. 25 years to go from the first GPU to Blackwell. But there's a nuance here, and this may answer your question or maybe shed some light on this, but when you scale logical qubits, it's not a linear Moore's law type of computational power increase. And they were talking about this on the earnings call. They said there's already this computational space that is so big, and by next year, so they're saying, like the 256 qubit system, and this isn't just like iPhone from 16 gigs of RAM to 32 gigs of RAM. This is like 16 gigs of RAM to the nth gigs of RAM every time we step up in these logical qubits. So I'm not as confident as you to know when a public or private company is going to release something that could be likened or akin to a GPT moment. Just with the private and public efforts that are happening right now in this space. Even Orca, for example, was saying they feel like by next year they could have, they call them qubos, or their photonic qubits. They feel like they could demonstrate quantum advantage as soon as 2026. So,
Yeah.
there's just so much going on, and there's so many companies in the space. It's very hard to predict the when that shoe drop moment is going to come. So I want to finish this interview by asking you, so for all the people that are interested in this space or investing, what are the greatest risks that still exist for quantum and investing in quantum?
Yeah, the number one biggest risk is encountering, again, physics that are not known, and because there's physics problems and engineering problems. Engineering problems are relatively easy compared to figuring out the physics. So once you go into a roadblock where you don't really understand the physics of your system, like that's a huge risk, right? Because then that derails you. Years, right? As was the case with superconducting qubits for a long time. So that's ultimately the biggest risk. The second risk is, and it's something that we've been struggling with, as investors in the private markets, is there's not enough talent. Like, nobody, gosh, like I studied physics and, it was dreadful. Like I didn't have a life. All my friends were in business school. I was studying. And, it's just not if you don't actually love physics, like you're not going to want to get into physics because you're just going to get your ass kicked. Right. And so we need to have some kind of, national consciousness program so that people want to learn physics, but also, quantum physics, go deeper, go into PhD studies, master's studies, so that we have access to the talent. And because it's funny because we kind of reached like a saturation point also in the number of quantum computing companies that were founded simply because there's only a few hundred, maybe a couple thousand people that you can actually hire that understand how this stuff works. And every startup that you talk to, like, what's your number one struggle? Like, where can we help? Do you need more money? No, we just can't hire people because they just don't exist.
There's a talent shortage.
There is. And, I understand to some extent, I understand the debate around H-1Bs and we got to keep, talent in the US, but, I'm sorry, but the US educational system is just horrible. Like we're cranking out humanities majors and we need more engineers, more physicists, more mathematicians, and it's a huge problem. And the other thing is
where China, I believe, has a distinct advantage. Their education system is very much STEM and very much engineering.
Oh yeah, absolutely. And I think also Europe is also quite competitive in this regard, which is why I think we've seen a lot of R&D coming out of Europe. I think the US is now starting to, pick up a little bit of speed and will eventually, but the US is going to have to import these people because, physics PhDs are, they're manufacturing them abroad. And if they are coming here to study, they're all on some kind of a visa. So that's the other risk is we need more people. And we can't do this without enough people. Like, fine, we have tools now, like AI tools that can actually help, researchers and physicists, get there, but it's not going to be enough. So that's the second risk. And then the third risk, obviously, I think a little bit less nowadays, is if we do see some sort of a pullback in the public markets, we're going to see also a pullback in the private markets, and then liquidity is going to dry up. And something, as a thesis for my next fund is actually, instead of focusing on the early stage, we need like Series B, Series C+. So like a lot of these later deals, we need to have a fund that's anywhere between, 1 to 1.5 billion that can write, $50 to $100 million checks to those companies that, got the Series B. They've got, let's say $100 million to $250 million valuation. But they're still in R&D mode. Like they're getting closer, but they don't quite have the commercial agreements, the commercial contracts that traditional growth investors look for. And unfortunately, like in quantum, like, when we've done investments, we've done seed and Series A. When we do investments, we look at revenue as sort of like interesting statistic, interesting metric. But the reason why we invest is because the technology is great, the team is great, and we know where it fits ultimately in the stack. And so we need more of that sophisticated capital at those later stages that also, there's more PhDs on staff than there are MBAs doing analyses, and that are willing to take the risk and write that check for 100 million because they know that, Rigetti or IonQ are going to acquire these guys because they fit nicely into their stack. Or we can find some exit liquidity, or we can find customers, public sector customers that are interested in just that part of the technology. So I would boil it down to those three.
Beautiful. Well, Dominic, this has been a very thought-provoking and multi-layered interview, looking at the private markets, the public markets, venture capital, the history of quantum computing, your personal perspective on everything. It's been great to learn. So where can people find you if they want to follow you or connect with you?
At Quantum Dom. I'm, Instagram, X is my primary weapon of choice. I've got a couple of blogs, although I should be writing more than I normally do. But mostly on Twitter. Catch me on Twitter. Reach out to me. If you're also not just an investor, but if you're a PhD in a lab somewhere, you've got some interesting technology, send me your paper. I want to read them. I'm technical. I love reading that kind of stuff, and always looking for exciting new investments.
Awesome. It was really a pleasure to have you on. Thank you for bringing your full suite of experience to the Quantum Bolt audience, and look forward to having you on again. Thanks, Dominic.
Thanks, Majid.
I hope you really enjoyed the content. I work really hard to deliver high quality content every day. If you would like to support my website and YouTube channel, I have 3 different membership options. I have the Quantum Bull, Gold Bull, and Diamond Bull. And each of those options has unique perks. If you'd like to join, just simply go over to the YouTube, click the plus button, and